Assalamualaikum and hello, my name is Muhammad Yusof, team leader for Team Java Nations. We are from University Polytech Malaysia and we are going to discuss about TSP algorithm. A travelling salesman problem is a problem of visiting each city once and go back to the beginning while finding the shortest possible route. This means that the TSP problem requires us to find the shortest path whilst allowing us to visit each city once and go back to the beginning city. There are 4 algorithms to solve the TSP problem, which is greedy algorithm, divide and conquer, dynamic programming, and backtracking. Now we are going to proceed with greedy algorithm.
Hello, my name is Nur Alisa and I'll be explaining about greedy algorithm. Greedy algorithm is a method that solves a problem by making the best choice at each step, but it does not look further into the problem to make decision and only make decision on what's best at the moment. It works by comparing each city distance from the starting city before it chooses the lowest distance from the current option of distance. In this code, the algorithm tries to find the nearest city at every step. First, the loop starts from 1 because the starting city is already chosen. Then the nearest city is set to -1 and shortest distance is set to maximum value. Next, the inner loop checks all cities one by one. The condition checks whether the city has not been visited and whether the distance from the current city to that city is shorter than the current shortest distance. If it is shorter, the program updates the shortest distance and stores that city as the nearest city.
My name is Alachimara. My algorithm is a divide and conquer. Okay, first point is a strategy that simplify complex problem is break big problem down into smaller sub problem. And the second point is we do this calling the function again to again the smaller part. Second is implementation is in a code each city array broken down into smaller sub problem. We solve distance for each city part individual. Next slide. Okay, this one is let me I show first is a calculation identify the every code. Okay, this one is the calculation 1 and this one is the calculation 2. Okay, next slide. Okay, this one is the calculation 3 and this one is the calculation 4. Okay, in calculation 1 is the all calculation route 1 to 16 and calculation 2 is a concrete is a which take the small number it is a which take the small number it is a 80 it is a route 2. Then calculation 3 is the just update the coding in the based on the code on the program. Okay, then finally is a combine is a for 2 is a route 2 is a to 4, but in combine formula is a tag which one is the early is so it is a router 2. So the final answer is the route 2. It is A B D C A.
My name is Adila and I'll be explaining about dynamic programming algorithm. I choose dynamic programming because it finds the shortest route efficiently by storing and reusing previous result. So for the coding, firstly is dynamic programming TSP. It's a method that initializes the memorization table and starts the search from CPA. Next is dynamic programming TSP helper. It explores possible routes to track a visited city. For mass visited all, it checks whether all cities have been visited so that the total distance is being calculated. For loop, it checks all possible next cities and if new cost, it keeps the shortest route found. So for the result, the memorization checks allow the program to reuse stored results instead of recalculating them, making the algorithm more efficiently. Finally, the algorithm checks all the unvisited cities, updates the minimum cost, and finds the optimal route. For our distance matrix, dynamic programming successfully finds the shortest route with a minimum cost of 80.
Hello, my name is Nur Atira. I will explain my part, which is backtracking. Backtracking is a method where we try all possible solutions step by step. Solutions are built incrementally, means we build it step by step, and it reduces unnecessary computation, which is we don't waste time checking back path. Next, here is my coding. I use 3 variables. First, visited to track visited cities. best cost to store the minimum distance, and best path store the best route. The main function is backtracking TSP. It initializes the variables and start from city A. Then it calls TSP backtracking, which is the core recursive function. These functions explore all possible paths using recursion. Next, there are two key parts. First, the base case. When all cities are visited, the program calculates the total cost including returning to the starting city, and it updates the base result if it is smaller. Second, the loop. The program tries all unvisited cities and only continues if the cost is still smaller than the current base cost. That's what we call is pruning. After choosing a city, it marks it as visited and calls the function again. Then it backtracks by unmarking the city try or the path. Next, this path is chosen because it gives the lowest total distance compared to all other possible routes. So the total cost of this route is 80, which is the minimum among all possible paths.
Sorting and searching is the fundamental computing tools used to organize data systematically and retrieve specific information efficiently. The role of sorting and searching is to aid the other algorithm in TSP algorithm. So for the algorithm of sorting is insertion sort, while searching is binary search. I'm Muhammad Yusuf and I'm handling insertion sort. So the algorithm is to take the value of an array X and compare it to the value beside it. If the value beside it is bigger than the array X, then the position of the value we're comparing it will be shifted to the current X position. If not, then the comparison stops and the comparison will be shifted to the next array until all of the array is sorted. So for the coding implementation, M is the limit of the loop, while N is the space inside the array begin with 1, as 0 is sorted. As long as N is less than M, the program will run. Key hold the current value at space N. O is to find the left array. If O is less than 0, that means we reach the end of the array and the while statement break. If value of array 0 is bigger than the key, the value of that space is moved to the right current of the space key. For the main method, we will send the city array to the static method so that it will be sorted. So the answer that we will get is like the example of unsorted city C, and we will get the sorted city C.
Hi, my name is Muhammad Sama Faris. My part is binary search. Okay, on binary search, algorithm divides the space into two halves by finding the middle index mid, the value target then being compared to mid. If the value is the same, then the program terminated, but if it isn't, then the search will continue to the left or the right based on the arithmetic logic. The implementation is search the city array by finding which site will it be located inside the array. Next is based on my coding. First, I use a string builder to request each step of the search process. And then next, left and right is define the search boundary, start and end of array. And then I use while loop, run as long as the search range is valid. And then I calculate the middle index by using left plus right divide by 2. And then I use 3 comparison logic. Firstly is the if array mid equal to target, target will found, and then the search is stopped there. But if not, if we go to the second comparison, that is if array mid lesser than target, the search continue in the right half. If not, and then the third comparison is if array mid greater than target, search continue in the left half. And then if not found, and then the loop ends, and then it will return target not found. This is the main method lah I use for searching. And then this is the sample output. Okay, that's all from me.